This class will work out two problems on RLC series resonance circuit. The first problem is a 5 ohm resistor is connected in series with the 0.05 Henry's inductor. Calculate the impedance, power factor, current. Second question is, if the resonance frequency is 50 Hz, what would be the capacitor to be connected in series with the inductor? In a resonance circuit, a circuit must consist at least one inductor, one capacitor. So if resonance frequency is 50, what would be the capacitor to be connected in series with the inductor? Second question. The third question is, if voltage across the capacitor is 2000 volts, what would be the voltage to be injected in the circuit to get the 2000 volts across the capacitor? For resonance frequency is 50 Hz. So I don't want to alter the resonance frequency. I don't want to alter the resistor, inductor and capacitor. Just I only want to increase the voltage to get 2000 volts. What is the voltage? That is the question. So first question is, calculate the impedance, power factor, current. So XL is equal to 2 pi FL. XL value is 15.71 ohms. R is equal to 5 ohms. Z is equal to root of R square plus XL square. Z is equal to 16.49 ohms. Cos theta is equal to R by Z, that is equal to 0.303. Theta is equal to 1.263 degrees lagging. Current I is equal to V by Z, 12.13 amps. So the current is 12.13 amps. Resistance is 5 ohm. Voltage across the resistor is 60.65 volts. Voltage across the inductor is 193.56 volts. Okay. The third question is, at resonance XL is equal to XC. 15.71 is equal to XC. 15.71 is equal to 1 by 2 pi FC. C is equal to 202.62 microfarads. So capacitor to be connected in series with the inductor is 202.62 microfarads. Over. Next I want to increase the voltage to get a 2000 volts. How to calculate the voltage? At resonance XL is equal to XC. Here voltage across the capacitor is given, that is 2000. Therefore I is equal to 2000 by 15.71, that is equal to 127.31 amps. Here the value is XC value is 15.71. XC is equal to 1 by 2 pi FC. I know the value of C, so I can calculate XC. IR is equal to 636.55 volts. IXL is equal to 2000 volts. Therefore, V is equal to root of VR square plus VL minus VC the whole square, that is equal to 636.55 volts. Here the voltage to be applied in the circuit is 636.55. To get the voltage across the capacitor is 2000 volts. Next I can calculate the quality factor. Quality factor Q is equal to voltage across the capacitor or voltage across the inductor divided by the applied voltage. Here voltage across the capacitor is 2000, applied voltage is 635.55, that is equal to 3.142. That is 142 times into supply voltage, you will get a 2000 volts. So here the voltage is magnified. Otherwise you can calculate Q is equal to 1 by R root L by C. You will get the same answer. Q is equal to 3.142. Here V is equal to 2000 by 3.142, that is 636.55 volts. Resonance frequency F is equal to 1 by 2 pi root LC. Here the frequency is, I have to get 50 Hz. Here L is 0.05 Henry. C is 202.62 microfarads. So the frequency is 50 Hz. At 50 Hz resonance frequency, the voltage is 635.55. I got a 2000 voltage across the capacitor. This way you have to work out this problem. The second problem is, a resistor, variable inductor and a capacitor. Three are connected in series. Supply voltage is 230 volt. Frequency is 50 Hz. By varying the inductor, the maximum current is 1.5 amps. That time Voltage across the capacity is 500 volts. Find the circuit parameters. First question. Second question is calculate the quality factor. Third question is calculate the bandwidth. You know the maximum current is 1.5 amps. Supply voltage is 230 volts. I can calculate resistance. R is equal to V by I. Resistance is 153.3 ohms. At resonance, XL is equal to XC. Voltage drop across the inductor is equal to voltage drop across the capacitor. So voltage drop across the capacitor is given 500. Therefore, VL is equal to 500, VC is equal to 500. So I into XL is equal to 500. I can find XL. XL is equal to 333.33 ohms. So now I can calculate L. XL is equal to 2 pi FL. L is equal to XL by 2 pi F. That is equal to 1.59 henries. Similarly, XC is equal to 1 by 2 pi FC. So C is equal to 1 by 2 pi into 50 into XC value, that is XC is equal to XL, 333.33, that is equal to 9.95 to 10 power minus 6 farads or 9.95 microfarads. Now I check the resonant frequency whether it will come 50 or not. Resonant frequency is equal to 1 by 2 pi root L into C. So I substitute L value 1.59, C value is 9.95 to 10 power minus 6 in this formula. The resonant frequency is 50. So R value is 153.3 ohms, L is 1.59 henries, C is 9.95 microfarads. Next I can calculate quality factor 1 by R root L by C. I know all the values. Substitute all the values in this formula. Q is equal to 2.61. Bandwidth is equal to FR by Q. So resonant frequency is 50, Q is 2.61, bandwidth is 19.16 Hz. Lower half power frequency F1 is equal to FR minus 0.5 into bandwidth, that is equal to 40.42 Hz. Upper half power frequency F2 is equal to resonant frequency plus 0.5 into bandwidth, that is equal to 59.58 Hz. Bandwidth is equal to F2 minus F1, that is equal to 19.16 Hz. This is the graph. Here the current value is 1.5 into 0.707. In that current, we got F1 and F2, the bandwidth is 19.16. This way you have to work out this problem. With this I conclude my lecture. Thanks for listening.